In this lesson, we're going to look a little bit more deeply into what the negative exponents are and what they mean. And they really have to do with these division problems. X to the fourth over x squared, for instance. I have two methods that I can use to simplify this. There's a little trick where I can, if the bases are the same, I can take the exponents and subtract them. So I would have x to the power of 4 minus 2, basically, which would be x to the power of 2. That works out great because I had a positive exponent, no negative exponents. The other method I could have done was to expand everything out. So I have the 4x's being multiplied in the numerator and the 2x's multiplied in the denominator. And I'm allowed to cancel the 2x's out with 2 of the 1's in the numerator, leaving x times x in the numerator, which is the same as x squared. But what happens if the leftover variables are left over in the denominator? So b to the power of 3 over b to the power of 6, if I use that same strategy as before, I end up with b to the power of negative 3. So what does negative 3 as an exponent tell me? Okay, I don't understand what that means. Like if I had the number 2 to the power of positive 3, that means I would do 2 times 2 times 2. But what does 2 to the power of negative 3 mean? What am I supposed to do with that? The negative exponent is an indication that something isn't quite right with this yet. Okay, and the reason is if I actually expanded those out, I would see that the leftover b's that are being multiplied are going to be in the denominator, not in the numerator. Everything in the numerator was canceled out, which means there's a 1 left over. And the only things left over in the denominator are b times b times b, or b to the third power. That means b to the power of negative 3 means 1 over b to the power of 3. In other words, the negative indicates to us that these 3 b's that are being multiplied, they're actually being divided in the denominator, okay? Whatever these b's stand for, 2, a 3, a 4, whatever, I'm multiplying and then dividing. And so I'm ending up with more division than multiplication. Same idea here, n to the fourth over n to the fifth. That's n to the power of negative 1 if I use the little trick. If I expand everything out, whoops, just hit the phone, I can see that everything is going to get canceled out except that one n at the very end. That tells me that I've got a 1 in the numerator and 1 n in the denominator. In other words, n to the power of negative 1 really means I'm taking that n to the first power in the denominator. Remember, there's always a 1 hanging out if you don't see an exponent. C to the third over c to the fifth would be c to the power of negative 2. We know that that's really 1 over c to the power of 2. Again, that would be c times c times c. Oop, I keep hitting the phone. Over c. All the c's on the top are going to cancel out, which means I leave a 1 in the top, and there's c squared on the bottom. And then this one's going to be kind of a regular one. V to the fifth over v. Remember, there's a 1 hanging out there. This would just be v to the fourth. No tricks. V to the fourth in the numerator by itself. Nothing to tell us that we're actually dividing here. Okay, so let's look at this a little bit farther here. Okay, the rule. When you find yourself with a negative exponent, you flip it to its other version. So x to the power of negative 3, this is really over 1. We just don't have to show the over 1 part. So this is the numerator, this is the denominator. We flip it. So now 1 is the denominator, and the numerator is x to the third, and you'll notice that it's no longer negative 3. That's because the negative tells me I'm in the wrong spot. So once we move it to the right spot, we don't need that negative sign anymore. Okay, if the negative exponent is on the top, like this one, you move it to the bottom, it becomes its positive version. If the number, the variable, is a base, or the base is a number or a variable, it means the same thing. So 3 to the power of negative 2 tells me these 3's are not in the right spot. They should be in the denominator. And of course, we can actually take 1 over 3 squared and actually do that multiplication. 3 times 3 is 9. So this is 1 divided by 9. Now, sometimes you'll find that the negative might appear in the denominator. We just flip it still. It's in the wrong spot. That indicates it's in the wrong spot. We flip it to the numerator. Okay, so that's really over 1. It flipped over. It became positive because now it's in the right spot. Same thing here, 1 over 2 to the power of negative 6. It flips over to the numerator. Now it's 2 to the power of 6, which I believe is 64. I hope that's right. 2 to the power of 6. 2 times 2 times 2 is 8. Yep, and 8 times 8 is 64. And there's that. Okay, so we're going to do a few practice problems here. N to the power of negative 8. That is the same as saying 1 over n to the power of 8. Okay, so it's in the wrong spot. 1 over x to the power of negative 2, it's in the denominator, and it's a negative exponent. That means it's supposed to go up to the numerator. And again, I don't have to show when the denominator is 1. I only have to show it when the numerator is 1. 2 to the negative 6th power, that's in the wrong spot. It should be 1 over 2 to the 6th power. And when you actually have numbers as bases, you should finish calculating them. 1 over 4 to the power of negative 2, wrong spot. Put it back where it goes. So 4 to the 2nd power over 1, I'm not going to show that this time though, which just equals 16. C to the negative 10th power, it's in the wrong spot. 1 over c to the 10th power. 1 over w to the negative 18th power comes to the numerator. D to the power of negative 23 would become 1 over d to the power of 23. M to the power of negative 3 equals 1 over m to the 3rd power. 1 over b to the power of negative 9 would be b to the 9th power. 4 to the power of negative 3 would be 1 over 4 to the power of 3, which we can figure out to be 4 times 4 times 4, which is 64. So 1 over 64. 1 over 6 to the power of negative 3, that's in the wrong spot, so we switch it back to the numerator. 6 to the power of 3, oh goodness. I know 6 times 6 is 36, but off the top of my head, I do not know what another 6 would be. So 36 times 6, 216. I feel like I should have known that, but I did not. 1 over b to the power of negative 5 is b to the 5th power. 1 over 2 to the power of negative 10 would be 2 to the power of 10. Ooh, that one, I'm not going to do that one in my head real quick. 1024. And 5 to the power of negative 4 is really 1 over 5 to the power of 4. Let's see. 5 times 5 would be 25. 25 times 5 would be 125. And 125 times 5 would be 625. Oops. Sorry, I shook the phone again. Okay. So these are the basics of how we're dealing with the negative exponents here. We're going to make it a little harder soon. Let's talk real quick about kind of why it works out this way. So I want to show you this sheet here because a lot of times in math, we can see how things work when we look at the patterns, okay? So for instance, if I start at the bottom of this list here, well, let's look at the list first. You see the base is always 2. And the exponent changes by 1 each time. Okay, so we're going to see this pattern emerge. So 2 to the power of 4, that's 2 times 2 times 2 times 2. That's 16. 2 to the 3rd power, 2 times 2 times 2 is 8. 2 to the 2nd power, 2 times 2 is 4. You'll notice that if I'm going this way, it's doubling every time because I'm multiplying by another 2 every time. And if I'm going backwards, it's splitting in half every time. So 2 to the power of 1 should be 2 because half of 4 is 2. That means 2 to the power of 0 should be 1, because half of 2 is 1. Okay, so it doubled, it doubled, it doubled, it doubled. So what's going to happen when we get to the negative exponents? Same rules should still apply. What's half of 1? 1 half. What's half of half? 1/4. What's half of 1/4? 1/8. And then 1/16. So let's see how these compare. 2 to the power of negative 1, remember, is 1 over 2 to the power of 1, which is the same thing as 2. 2 to the power of negative 2 is 1 over 2 to the power of 2. We know 2 to the power of 2 is 4. 2 to the power of negative 3 is 1 over 2 to the power of 3. 2 times 2 times 2 is 8. And you can see where we're going with this. 1 over 2 to the power of 4 is 16. I get 1/16. Okay, so what you can see here is that as we go backwards into these negative exponents, I'm ending up with these fraction answers. And that's because the numbers are getting divided instead of multiplied. Okay, 2 to the power of 0 starts us off at 1, and then from there everything doubles. Or going backwards from there, everything gets cut in half. We can see the same thing happening with 3 as the base. Okay, so 3 to the power of 0 we know is going to be 1. 3 to the power of 3 to the power of 1 is just the number 3. 3 to the power of 2 is 9. So you see now everything is tripling instead of doubling. 3 to the power of 3, that's 3 times 3 times another 3. It's 27. And then 3 times 3 times 3 times 3. So I am tripling it again. Let's see, 3 times 3 would be 9 times 9 is 81. Okay. So I tripled as I'm getting bigger and bigger. If I put 3 to the 5th here, it would be 81 times 3. Now going backwards, I should be dividing by 3. So 1 becomes 1/3. 3 to the negative 2 should be 1/9. 3 to the negative 3 should be 1/27. 3 to the negative 4 should be 1 over 81. Okay, 3 to the power of negative 1, that's 1 over 3 to the power of 1 when we switch it around. 3 to the power of negative 2 is 1 over 3 to the power of 2. 3 to the power of 2 is 9. 3 to the power of negative 3 is 1 over 3 to the power of 3, which makes 1 over 27. And then finally we have 1 over 3 to the power of 4, which makes 1 over 81. So it's nice to see how that kind of works out there, where we can really see what's going on and kind of understand how and why these negative exponents do what they do. Okay. What happens when we have lots of negative exponents? Okay, so the basic rule here, parts that are positive can stay where they are. Parts that are negative need to be switched up or down. Okay, so here in this case, 15, a to the negative 3, b to the 5th, over 3, c to the negative 8th. Okay, 15 and the 3 stay where they are. A to the negative 3rd gets bumped down. He's not supposed to be in the top, he's supposed to be in the bottom. B to the 5th stays because he's already positive, he's where he's supposed to be. C to the negative 8th gets bumped up to the numerator because he's in the wrong spot in the denominator because of the negative exponent. And from there, we can simplify. So 15 divided by 3 became 5. There was nothing else to simplify, so it just stayed the same. Okay. Sometimes, though, after we move exponents around, we might find some other bases that we can kind of combine. They might come up, for instance, on this one right here, y to the 5th, y to the negative 3rd, y to the 3rd came up, and it can be combined now, y to the 8th, okay? Another method that you could do, it's not as popular, is you could still do the subtraction method and say this is 5 minus negative 3. But you got to remember that minus negative 3 makes positive 3. So 5 plus 3 is how you would get 8 in the end. A lot of people find it easier, though, to move everything around to the correct spot first and then kind of take inventory of what there is. If you'll remember from a previous lesson, y to the 5th times y to the 3rd, you just add the exponents when they're in the same, either in the numerator or the denominator together. So we're going to fill in these blanks here to kind of show what happens in the to the negative exponents as they are turned positive. Okay, let's start with the 2 and the 12. Okay, they're not going to change, so 2 and 12. y to the something and then y to something. We're going to put two y's at the top here. Obviously, one of them will be y to the fourth. It's in the right spot already. The other one must be this one. Y to the negative fifth needs to come up to the numerator to be in the right spot. W to the what? That must be w to the fourth power, which is already in the right spot. X to the power of, so it was negative 3 in the numerator. It's going to come down and be x to the power of positive 3 in the denominator. And then z to the 10th is already there. And now we're also going to put z to the 5th down here as well. Okay. Now, 2 over 12, that does not divide evenly. What I get is 1/6. And you'll notice there's not a spot for a coefficient here because you don't have to show the 1 in the numerator. If I wanted to, I could. I'll go ahead and write it. There's a 1 there, but you don't have to show it. You do have to show the 6 though. 6 is an important number. Y to the what? So we're gonna combine these now. Y to the fourth times y to the fifth. 4 y's being multiplied, 5 more being multiplied. That is 9 total y's being multiplied. W doesn't have anything to combine with, so it's gonna stay w to the fourth. X doesn't have anything to combine with, so it's gonna stay x to the third. But z, there's 10 of them here and 5 of them here being multiplied for a total of 15. Okay, so the last little bit that we're gonna practice here is how to do this without those boxes. Okay, so here's how I like to start. I look at the coefficient, so 50 over 10, that's 5 over 1, so it's just 5 basically. And then I go piece by piece. A to the 6th, that's good, it stays there. B to the negative third, wrong spot, drop them to the bottom. Okay, so I've taken care of everything on the top. 10 already got taken care of, remember it was 50 over 10. C to the negative 2, the negative tells me it's in the wrong spot, it goes back up here, okay? There are no bases that are the same that I can kind of clean up. We'll call it a cleanup afterwards. So instead, I'm just going to kind of center everything a little bit nicer. This is the exact same expression as this. I'm just centering it instead of having b to the third way over here. I didn't know if there was going to be anything else coming to join b to the third, so I left lots of room there. Okay, 18 divided by 6 is 3. N to the negative fifth is in the wrong spot. It needs to come down here where it can be positive. M to the negative 2, wrong spot. It's going to come down here and be positive. I already took care of the 6. 18 divided by 6 was 3. N to the negative 6th power needs to go upstairs to the numerator. M to the 4th is already positive. It's already in the right spot, so don't move it. All right, what can we clean up here? I've got 6 n's multiplied on the top and 5 on the bottom. If I were to expand those out, these 5 are going to cancel out with 5 of the ones on here, and I'm going to be left with 1 n in the top, in the numerator. The other method is to just simply do 6 minus 5 and get 1, so an exponent of 1. So 3n is all that's left over in the numerator. These m's can be combined in the denominator. M squared and m to the 4th. So first I'm going to take 2 m's, then I'm going to multiply 4 m's for a total of m to the 6th. Okay, 4 over 8. That's a fraction that we can reduce. It's going to become 1/2. 4 over 8 becomes 1/2. X to the negative 3 drops to the denominator. Y to the negative 2 drops to the denominator. Z to the negative 8 drops to the denominator. X to the power of negative 3 moves to the numerator. Y to the 2nd power needs to stay. It's already good. Ooh, z to the 0 power. Just cancel that guy out. He's going to turn into a 1. There's lots of other things down here. It doesn't matter if I'm going to multiply by a 1. I'm just going to ignore it. He's gone forever. Okay, so the cleanup time. X to the 3rd over x to the 3rd. If I expand those out, they're all going to cancel each other out. So that guy's gone completely. The only thing left over in the numerator is a 1. So I have to keep it. Then we have a 2 in the denominator. And I have y to the 2nd and another y to the 2nd. That's going to make y to the 4th, and then z to the power of 8. Almost done here. We got 2 problems left. 6 divided by 2 makes 3. W to the power of negative 8 is in the wrong spot. It needs to come down to the denominator. X to the power of negative 3, wrong spot. Y to the 6th, that's a good spot for it. It's positive already, it's in the right spot. We took care of 2 already. 6 divided by 2 is how we got 3. W to the power of negative 3, wrong spot, needs to get moved to the numerator. And then x to the power of 4 is in the correct spot. We leave it in the denominator. Now we clean up. 3 is going to be on top still. There is nothing to cancel out or combine with the y to the 6th, so it's going to stay y to the 6th. W to the 3rd and w to the 8th. Okay, if I subtract 3 minus 8, I get 5. So w to the negative 5th power, when I use the subtraction method, remember, it always ends up being in the numerator. So w to the negative 5th power is in the wrong spot. It must be w to the 5th power in the denominator. The other way of thinking of it is if I expand these out, where are all the leftover w's going to be? These 3 will cancel out with 3 of the ones here. All the leftovers are going to be in the denominator. And then x to the 3rd times x to the 4th. We're not canceling anything out. We're just saying, oh, there's 3 x's, and I'm going to multiply 4 more right after. Might as well call that x to the 7th power. And our last one here. So 15 divided by 25. That does not divide evenly, so we're actually going to treat it like a fraction and reduce it. Okay, if I divide 5 out evenly, I would get 3/5. C to the 1st power stays where it is. It's positive. D to the negative 10th power is in the wrong spot. It's going to go downstairs. I already took care of 25. C to the negative 3rd, wrong spot. Now it's upstairs in the correct spot. D to the 4th is the correct spot. And E to the 4th is the correct spot. Now we do the cleanup. How many C's are being multiplied on the top here? C to the 4th. How many D's are being multiplied in the denominator? 10 here and 4 here for a total of 14. And then E to the 4th doesn't have anything to join up with. It's going to stay like that. And that is our lesson on negative exponents. Basic idea is if you see a negative exponent, it's telling you, hey, I'm in the wrong spot. If I'm in the numerator, I should be in the denominator. If I'm in the denominator, I should be in the numerator. And once you make that change, it's no longer going to be negative. It's going to be positive now to show that it is in the correct spot after that.